Hello once again, Mr. W and Professor Marcus here with you to do another classroom chemistry experiment. And this one we are going to create carbon dioxide gas using two different methods. One will be through a physical change and one will be through a chemical change. We're going to start with the chemical change. So we're going to have two regular kitchen substances that you probably have at home. So you could try this experiment with your parents' permission, of course. So Marcus, what is this powder?
Baking soda.
Baking soda and
Vinegar.
this is vinegar. When we combine the two, we will create carbon dioxide gas. And we know it's a chemical change because the new substance that we create, we're going to do it in this cup, is no longer going to be vinegar or baking soda. It's going to be a new substance. And there's going to be bubbling happening. And as all gases, secret identities, as all gases are invisible, we're going to use a candle to prove that the carbon dioxide gas is here. Kids don't play with fire, right? So get an adult to light your candle.
Kids play with fire.
So we just have a tea light and a little cup here. Do you know one thing that fire needs to burn? What's something around it that...
Air.
Air.
Blow out air on it and then make a fire and can kill people.
So specifically the part in the air is oxygen. Now carbon dioxide gas, if we indeed create it, it's heavier than air, it'll sink, but it will push all that oxygen out of the way. So, Professor Marcus, can you dump a little bit of the baking soda into the cup?
How much? Can I handle?
No, just a little bit. Go ahead. Okay, that's good. You can see how it's all bubbling.
Can I try? Can we put some more
A
salt?
gas was obviously formed. That's what created the bubbles. Now watch. The liquid is at the bottom there. I'm just going to mix it up a little bit.
I like this.
Thank you. And watch. Ready for the magic?
Yeah.
Don't blow. You can see none of the liquid was poured out.
Can we try it again?
That part is just the wax, but in here we could see that it's perfectly dry.
Do something again.
So what do you think happened there? Why did the candle go out? You didn't blow on it, did you? No. So what do you think happened?
It's like sand.
Well, sort of. Sand, if we put on fire, it would, can you sit please? Sand would push away the air, and that's what the carbon dioxide gas did. It pushed it away. All right? So that's creating carbon dioxide gas using a chemical change. We are now going to create carbon dioxide gas using a physical change, not a chemical change. Do you have any ideas how we could do that? With dry ice? Sure, let's give that a shot. If regular ice is frozen water, what do you think dry ice might be?
It's super cold ice. It's like 100 degrees.
Well, you're not too far off, Professor Marcus. It is super cold ice. It's about minus 80 degrees, which is much colder than your freezer could be. It's much colder than any winter day.
100.
It's about minus 80.
It's more than the North Pole.
So, yes, it's colder than the North Pole. So we just happen to have some dry ice right here. Hang on, please. Now, dry ice, like we said, is so cold that it could give you instant frostbite, so we're not going to touch it with our bare hands. And another word of caution for you kids at home is that dry ice can be dangerous in multiple ways. I am a trained professional. I know what I'm doing. I know how to handle it. Do not ever play with dry ice. See the magic happen when I just pour some warm water over the dry ice. Professor Marcus, you're missing some cool stuff here.
I just getting this.
Oh, getting gloves. Good thinking. Now, watch what happens. Remember, carbon dioxide gas is heavier than air, and we could see that here as it's sinking down to the table. No? No blowing, please. Watch what happens when we tip it over the fire.
Can I go touch the ice now?
Again, no liquid went in there. It was just the carbon dioxide gas. So let's try that one more time. Do you want to try it this time, Professor Marcus?
Yeah. Touch the ice.
No, you're just going to tilt the gas into the cup.
This is good as close.
Just tilt it a little bit, yep. Dry ice is frozen carbon dioxide. When it turns to gas, it is still carbon dioxide. This is simply a change of state of matter and therefore only a physical change. When a solid turns straight into a gas, we call that sublimation. It's still the same substance, and so it is only a physical change. We are now going to try another little experiment. Professor Marcus is going to wait patiently. I have some dry ice nuggets, some warm water, and in this bowl here, I just have some soapy water and a piece of paper towel. A cloth will work. We're going to try to create a dry ice bubble. All right, go ahead, Professor Marcus. So here we have our dry ice. Okay, that's good, thank you. We're just going to bring it to the middle of the table here.
Yeah, put some.
Nope, thank you. We're gonna wait till it settles down a little bit. It's hard to see right now, but if you look down there, it looks like what boiling water would look like. Okay, thank you, Professor Marcus. It looks like boiling water. Do you know why it looks like it's boiling down there?
Because it's ice and hot water.
It is ice and hot water. That water is actually very cold. A gas is not being formed, but a gas is being released. Take your hand out, please. A gas is being released. Do you know which gas?
Carbon dioxide.
Carbon dioxide gas.
It might not work.
It may not work. Science experiments don't always work.
We already tried it.
Whoa, look at that go.
Look at that rainbow bubble.
Okay, no blowing. So the carbon dioxide gas was filling up the bubble. And
Can I
then,
try again?
once the surface tension was broken of the bubble, then it burst. We're going to try one more time. So I'm just creating this bubble across this cup.
Daddy, it's rainbow.
Yes, you can see it because the bubble kind of acts like a prism.
It's a prism.
All right,
What's a prism?
let's watch this bubble form. We can see the gas being released at the top. The gas is now rising up and filling up the bubble.
The balloon.
It looks like a balloon, yeah. Do you want to blow it?
Yeah.
Go. Today we learned how to create carbon dioxide gas using both physical and chemical changes. Right, Professor Marcus? Where's Professor Marcus? Professor Marcus! We lost you! Where'd you go? Swim, Daddy, swim, swim! Oh, it's okay, little baby. Don't be scared.
Back patrol! Back the patrol!